What makes a tiny wristwatch keep perfect time for years? Why do some watches never need a battery while others rely on quartz crystals? Today, we'll discover the fascinating engineering behind mechanical and quartz watches. The humble wristwatch represents one of humanity's most remarkable engineering achievements. Think about it. Hundreds of microscopic components working together in perfect harmony, measuring time with incredible precision, all within a device smaller than a cookie. From the battlefields of World War I, where soldiers first strapped pocket watches to their wrists for quick time checks, to the modern smartwatches on our wrists today, timepieces have evolved dramatically. Yet the fundamental technologies powering traditional watches remain largely unchanged. Mechanical watches, some containing over 300 hand-assembled parts, continue to captivate collectors and engineers alike with their intricate craftsmanship. Meanwhile, quartz watches revolutionized the industry in the 1970s, offering unprecedented accuracy at a fraction of the cost. Both technologies coexist today, each serving different needs and preferences. Understanding how these miniature machines work reveals not just the passage of time, but centuries of human ingenuity, precision engineering, and the relentless pursuit of perfection. The story of watches begins centuries before the wristwatch existed. Early mechanical clocks appeared in European monasteries during the 13th century, using weights and gears to mark the hours for prayer. These tower-sized machines laid the groundwork for miniaturization. By the 16th century, craftsmen had shrunk these mechanisms into pocket watches, portable timepieces that became symbols of wealth and status. The wristwatch emerged from necessity during World War I, when soldiers needed hands-free time coordination for military operations. What started as a practical battlefield tool quickly became a fashion statement and engineering showcase. For nearly 4 centuries, mechanical watches reigned supreme, with Swiss and German manufacturers perfecting the art of precision timekeeping. Then came the quartz revolution. In 1969, Seiko introduced the Astron, the world's first quartz wristwatch. This battery-powered marvel used a vibrating quartz crystal to keep time with accuracy that made mechanical watches seem obsolete. The Swiss watch industry, which had dominated for generations, nearly collapsed as inexpensive quartz watches flooded the market. Yet mechanical watches survived, even thrived, because they offered something quartz couldn't replicate: the soul of traditional craftsmanship, the visible artistry of moving parts, and the connection to centuries of horological history. Today, both technologies coexist, each serving distinct markets and purposes. Let's explore the mechanical watch first, starting with its power source, the mainspring. Imagine a tightly coiled ribbon of metal, wound by turning the crown on the watch's side. This spring stores energy, similar to how a compressed spring in a toy car holds potential energy. As the mainspring slowly unwinds, it releases this energy gradually through a complex system of gears called the gear train. The center wheel connects directly to the mainspring barrel and makes one complete rotation every hour, driving the minute hand. The third wheel increases the rotational speed, passing energy to the fourth wheel, which rotates once per minute and moves the second hand. But here's the challenge. If the mainspring simply unwound freely, the watch would run too fast and stop within seconds. The watch needs a regulator, something to control the energy release precisely. This is where the escapement mechanism comes in, the true heart of any mechanical watch. The escape wheel has specially shaped teeth that interact with 2 small pallets on the lever. As the balance wheel oscillates back and forth, it allows the escape wheel to advance by exactly 1 tooth at a time, creating that distinctive ticking sound. The balance wheel, a weighted circular wheel, swings back and forth, powered by a delicate hairspring that coils and uncoils with perfect rhythm. The balance wheel typically oscillates at 28,800 beats per hour, or 8 beats per second, though some high-end watches beat even faster for greater precision. This oscillation is regulated by the hairspring, an incredibly thin coil of metal alloy that expands and contracts with temperature changes. Modern watches use special alloys that resist magnetic fields and temperature variations. Now, notice those tiny ruby-colored components throughout the movement. These aren't decorative, they're synthetic jewels, usually rubies or sapphires, serving as nearly frictionless bearings for the rotating gears. In high-quality watches, you'll find 17 to 25 joules, reducing wear and friction. Automatic watches add another layer of sophistication: a semicircular rotor that spins freely with your wrist movement. This rotor connects to the mainspring through a complex winding mechanism, automatically keeping the watch powered as you wear it. Manual watches require daily winding by turning the crown, directly tensioning the mainspring. The power reserve indicates how long the watch will run on a full wind, typically ranging from 40 to 80 hours, though some watches achieve a week or more. Swiss movements represent the gold standard, adhering to strict tolerances and finishing standards. Every component must work in perfect synchronization, each gear precisely cut, each jewel perfectly positioned, all within a space smaller than a coin. Quartz watches operate on completely different principles, replacing mechanical complexity with electronic precision. At the heart of every quartz watch lies a tiny crystal of silicon dioxide, the same mineral found in common sand. But this crystal has a remarkable property called piezoelectricity. When you apply electrical voltage to it, it vibrates. The battery sends a small electrical current to the quartz crystal, precisely cut to vibrate at exactly 32,768 times per second. Why this specific frequency? Because it's a power of 2, making it easy for electronic circuits to divide down to exactly 1 pulse per second. An integrated circuit, essentially a miniature computer chip, counts these vibrations and divides the frequency down repeatedly, first to 16,384, then 8,192, continuing until it reaches precisely 1 pulse per second. This 1-second pulse activates a stepper motor, a tiny electromagnetic coil that converts electrical pulses into mechanical motion. The stepper motor advances a gear by one precise increment, which then moves through a small gear train to the second hand, minute hand, and hour hand. The entire system consumes incredibly little power. A typical watch battery, smaller than a button, can power a quartz watch for 2 to 5 years. Compare this to a mechanical watch, which stores perhaps 40 hours of energy in its mainspring and requires constant motion or winding. The manufacturing processes for these watches reveal why prices vary so dramatically. Modern watch production combines advanced CNC machining with traditional handwork. Computer-controlled machines mill brass or steel blanks into precise gear shapes, with tolerances measured in microns, thousandths of a millimeter. Specialized machines cut the teeth on each gear wheel, ensuring perfect spacing and depth. For mechanical watches, jewel installation requires incredible precision, pressing synthetic rubies into exact positions to serve as bearings. The mainspring, a ribbon of hardened steel, undergoes heat treatment to provide consistent tension over thousands of unwindings. Assembly represents the most delicate phase. Watchmakers, often working under microscopes, position each tiny component with tweezers finer than human hair. A single speck of dust can stop a movement, so assembly occurs in controlled cleanroom environments. The dial, often considered the watch's face, receives hand-applied hour markers and brand insignia. Hands, sometimes thinner than paper, are pressed onto their respective posts with specialized tools that apply exact pressure. The case, whether stainless steel, gold, or titanium, undergoes extensive polishing, sometimes for hours, to achieve a mirror finish. Crystal installation, whether mineral glass or scratch-resistant sapphire, must create a perfect seal. Water resistance testing involves submerging watches in pressure chambers simulating diving depths. Finally, precision calibration adjusts the timing accuracy, with luxury watches regulated to within seconds per day. Comparing mechanical and quartz watches reveals fundamental trade-offs. Accuracy favors quartz dramatically. A standard quartz watch gains or loses about 15 seconds per month, while mechanical watches typically vary by 4 to 6 seconds per day, sometimes more. High-end mechanical chronometers, certified by official testing institutes, achieve plus or minus 2 seconds daily, still far less accurate than basic quartz. Maintenance requirements differ substantially. Mechanical watches need professional servicing every 3 to 5 years, involving complete disassembly, cleaning, lubrication, and reassembly, costing hundreds of dollars. Quartz watches require only battery changes every few years, usually under $20. Durability depends on usage. Mechanical watches contain delicate components susceptible to shock damage, though modern shock protection systems help. Quartz watches, with fewer moving parts, generally withstand impacts better. Cost ranges dramatically. Simple quartz watches start under $20, while basic mechanical watches begin around $200. High-end mechanical watches reach tens or hundreds of thousands of dollars. Lifespan differs too. Well-maintained mechanical watches can last generations, even centuries. Quartz watches depend on electronics availability. If the circuit fails after decades, replacement parts may not exist. Craftsmanship represents perhaps the biggest divide. Mechanical watches showcase visible artistry, traditional skills, and engineering heritage. Quartz watches demonstrate modern precision and practical efficiency. Collectors prize mechanical watches for their complexity and traditional craftsmanship. Most people choose quartz for reliability, accuracy, and affordability. Luxury watchmaking elevates mechanical movements into genuine art. High-end manufacturers employ techniques unchanged for centuries. Hand finishing includes Geneva stripes, also called Côte de Genève, decorative parallel lines applied to bridges and rotors using specialized polishing tools. Perlage creates circular patterns on plates through repetitive circular brushing. Anglage involves hand beveling every edge to 45 degrees, then polishing to a mirror finish, a process requiring days per movement. Skeleton movements remove non-essential metal from bridges and plates, revealing the mechanism's inner workings, transforming functional components into sculptural elements. Complications add functionality beyond basic timekeeping. The tourbillon, invented in 1801, places the escapement in a rotating cage, theoretically improving accuracy by averaging out positional errors, though modern materials have reduced its practical benefit. Today, it serves primarily as a demonstration of watchmaking mastery, with some tourbillons costing more than luxury cars. Chronographs add stopwatch functionality, requiring additional components and pushers. Moon phase complications display the lunar cycle through a rotating disk behind a shaped aperture. Perpetual calendars automatically account for months of different lengths and leap years, remaining accurate for decades without adjustment. These complications can involve hundreds of additional parts, all fitting within the same compact case. This explains why some watches cost as much as houses. Hundreds of hours of skilled labor, traditional handcraft techniques, precious metals, and generations of accumulated expertise, all devoted to measuring something we can check on our phones.